In quadratic function, Mr. Ihab Ismail Ahmed. Learning outcomes create, interpret, and analyze quadratic functions that model real-world situations. A. Use first and second difference to create models that represent data. Interpret the functions based on the real-world situations they model. Graph quadratic function. Use the first and the second difference. What is the kind of the relation of the following table? Table 1, x equal 0, 1, 2, 3, 4, y equal 2, 3, 4, 5, 6. What's the difference between values of y? y2 minus y1, 3 minus 2 equal 1, 4 minus 3 equal 1, 5 minus 4 equal 1, 6 minus 5 equal 1. It's constant. First difference, constant. We can say, we can see we can see that the first difference in each case is constant. This tells us that is the linear relationship. But turn the type of the relation in the following table. X equals 0, 1, 2, 3, 4. Y equal 2, 3, 6, 11, 80. First difference, 3 minus 2 equal 1. 6 minus 3 equals 3. 11 minus 6 equal 5. 18 minus 11 equals 7. Not equal, not constants, but second difference, 3 minus 1 equal 2, 5 minus 3 equal 2, 7 minus 5 equal 2. It's constant. We can see. The second difference is constant. This is important because it tells us that this a quadratic relationship. Activity 1. X equal 1, 2, 3, 4. Y equal 3, 1, negative 3, negative 9. First difference, 1 minus 3 equal negative 2. Negative 3 minus 1 equal negative 4. Minus 9, negative 9 minus negative 3 equal negative 6. Not equal, but negative 4 minus negative 2 equal negative 2. Negative 6 minus negative 4 equal negative 2. It's constant. Equations that represent a quadratic function. There are three forms to the equation of a quadratic function. The first form is standard form. Y equal ax power 2 plus bx plus c. But the second form, factor 4, y equal ax minus s times x minus t. The third form, vertex form, y equal ax minus h power 2 plus k. Graph quadratic function. The standard form of a quadratic functions is f of x equal ax power 2 plus bx plus c. Graph y equal x power 2. Graph y equal x power 2. The graph is represented by a parabola opened upward, y, a positive, a factor of x power 2 is positive. So, parabola open upward. Find the domain and the range. Domain, real number, from negative infinity to positive infinity, but range from 0 to infinity of the graph. Graph equal y equal negative x power 2. This graph, y equal negative x power 2. The function is represented by a parabola open downward, down. Why? Because a factor of x power 2 is negative minus 1. What is the domain and the range of the function? Domain, real number, x-axis, but the range from 0 to negative infinity. Notes. The standard form of the functions is f of x equal ax power 2 plus bx plus c, and a don't equal 0. Assumptions in standard form of the functions is a not equal 0. The parabola was open upward when a is positive, but the parabola is open downward when a is negative. The coordinate of the vertex of the parabola is the point, the slope, negative b over 2a, and fo negative b over 2a. Activity. Graph the functions of x equal to x power 2 minus 4x minus 1. Then, find the domain and the range. Solution. A equal 2, B equal negative 4, C equal negative 1. Then the vertex is point is 1 and negative 3. Why? This law, negative b over 2a and f of negative b to a. Point equal 1 and negative 3. And the graph is opened upward. Why? Because a factor of x power 2 positive. This graph opened upward because the factor of x power 2 is positive. The domain is R, real number, on a x-axis from negative infinity to positive infinity. But range is negative 3 to positive infinity, negative 3. The axis of symmetric is x equal 1, x equal 1, x equal 1. Activity. Graph the functions y equal negative x power 2 plus 2x plus 1. Then find the range, domain, and the equation of axis of the symmetry. This graph factor x power 2 is negative. So this graph domain real number, but range from 2 to negative infinity.